Today we will talk about Newton's second law of motion. So, the second law states that force applied is proportional to the rate of change of momentum. Now, in order to explain the force, we have to learn about momentum. So, momentum is nothing but the mass of the body times velocity. So, momentum is m times v. And what are the units of this one? Is kg meter per second. So kg times meter per second. And since velocity is vector quantity and mass is scalar quantity, the product of these two is a vector quantity. So momentum is a vector quantity. So we have to understand it's a vector. And Newton's second law states that the force applied is proportional to the rate of change in momentum. That is, force is equal to change in momentum over time. Rate is always with respect to time. Change in momentum over time is called rate of change of momentum. And you know that if this m is pulled out, then v final minus v initial over time, which is acceleration, which we have learned in a motion in one dimension. So force is mass times acceleration, and the unit of force is Newton, N, capital N, standing for Newton. And also, is it a vector or a scalar? Acceleration is a vector, mass is scalar. So force is a vector quantity. It has a direction and magnitude. So force is a vector quantity, momentum is a vector quantity, acceleration is a vector quantity, velocity is a vector quantity. So we got to understand, in Newton's second law, we have understood that there is something called as momentum, which is mass times velocity, and there is force, which is mass times acceleration. So it's very simple, and wherever we go, we know we require mass value, final velocity, initial velocity, and acceleration values so as to calculate what we want. So this is about Newton's second law of motion. So from Newton's first law, we got a term called force and inertia. Inertia is nothing but mass. And we got a term force which he defined in the second law. And to calculate force, we require a rate of change of momentum. So if you know the final velocity, initial velocity, time, then you can calculate acceleration and force can be calculated. Force is measured in newtons. When you write Newton, you'll write Newton like this. You will not write a capital letter. You'll write a small letter, Newton. And there is no newtons, no plural. Newton itself is singular and plural. And the momentum like this you'll write. And it's a vector quantity. This is also a vector quantity. So this is about momentum and force. In the next class, we'll talk about the third law of